Welcome back, everyone, to the Deep Dive. This Deep Dive is presented by Bluewater Auto Restoration. I'm your host, and glad to have you with us. This is week 36 of the 2025 Bluewater Auto Restoration Deep Dive. As always, we drop these every Saturday morning, hopefully giving you something interesting to listen to over the weekend. Today, we are tackling something that, well, it might seem mundane at first, but it's actually a fascinating intersection of old tech and new tech in our cars. Electronic versus manual parking brakes. Which one is actually better? You know, it feels like every single year, something else in the car we just took for granted gets a complete digital overhaul. We've seen this huge shift, almost everything moving away from physical mechanical controls towards screens and buttons. And believe it or not, even the parking brake, something so basic, is right in the middle of this tech evolution. So the big question we're asking today, and asking you to think about, is, are these new electronic systems always an improvement? Or is there still a really solid case for the traditional, the manual way of doing things?
We're talking about the handbrake, the foot brake, the e-brake, emergency brake. Some people even call it the drifting mechanism, maybe not officially, but let's unpack this whole thing.
Yeah, and it's fascinating, isn't it, how something seemingly so simple, just holding your car still, actually touches on so many things. We're talking safety, obviously, but also day-to-day convenience and even just how the car feels to interact with. So this deep dive, it's not just going to be a list of features. We really want to get into the nitty-gritty, the nuances, understand the engineering choices, the trade-offs manufacturers are making that affect you, the driver. Our mission today really is to explore the pros and cons of both manual and electronic systems, really dig in. And as we go through the mechanics, the good points, the bad points, some of which might surprise you, I'd really encourage you, the listener, to think about your own driving. What do you prefer? What kind of car do you drive? What matters most to you when it comes to controlling your vehicle? Because honestly, the better system often just boils down to what you prioritize.
That's a great way to frame it. So before we get tangled up in the which is better debate, maybe we should just level set. How do these things actually work? Whether it's a lever you yank or a button you push, what's the basic principle that stops the car from rolling away?
Yeah, absolutely the right place to start. Because fundamentally, the core idea, the physics behind most parking brakes, it's actually quite similar to how an old school drum brake works. Or, more accurately, a lot of cars integrate a small drum brake mechanism specifically for the parking brake, often inside the rear wheel assembly. So picture this. Inside the hub, or sometimes it's nestled within the hat section of your rear disc brake rotor, you've got these things called brake shoes. Now, when you engage the parking brake, pull the lever, push the button, whatever it is, a mechanism gets activated. Could be a simple steel cable, could be a little electric motor, but its job is to push those brake shoes outwards, and they press really hard against the inside surface of a drum, or that inner part, the disc rotor. The key thing here is friction. Massive amounts of friction are generated, and it's that friction that physically locks those rear wheels solid, stops the car from moving. So if you think about the bigger picture, it's like a dedicated mechanical lock, totally separate from your gearbox. It's a critical safety backup. Ensures the car stays put even if the transmission isn't holding it, or, heaven forbid, your main brakes failed. It's an independent system.
Okay, so it's like a secondary brake system, usually on the back wheels, just for parking or maybe emergencies. You mentioned the drum-style mechanism. That's interesting because, most modern cars have disc brakes all around, don't they? So where do we still typically find this sort of fundamental drum-style parking brake setup today?
Well, you'll find that dedicated drum-style system, or often what's called a drum and hat design, where it's built into the center of the rear disc rotor quite widely, actually. It's really common in, say, more affordable entry-level cars. Or vehicles designed for more utilitarian purposes, where things like cost, toughness, and simple maintenance are really important. Think about cars in many global markets, like maybe a Toyota Wigo, practical, economical. They often use this proven design. Or workhorse vehicles like a Mitsubishi L300 van, something used for heavy loads, commercial stuff. They'll often have it too. So these examples kind of show that this basic principle, it's still very relevant, still reliable across different types of vehicles. It's chosen for being durable and mechanically straightforward. It's kind of a testament to a design that just works, even while other car tech gets super complicated.
Okay, that really clarifies the basic principle. So we've got the groundwork laid, how these brakes hold us still. Now let's talk about the system, the one I grew up with, and probably most listeners did too, the manual parking brake. There's just something so satisfying about that clicking, that ratcheting sound when you pull the lever up, isn't there? It feels very physical, like you're directly doing something mechanical.
Oh, absolutely. That tactile feedback, that feeling, it's a huge part of why it's still loved by so many drivers, not just nostalgia. With the manual brake, you, the driver, are directly causing a purely mechanical action. You grab a lever or maybe step on a pedal, and that's physically connected, usually by a steel cable, sometimes a couple of cables, right to the rear brakes. So when you pull that handbrake lever or push down on the foot pedal type, you're literally tightening that cable, and that force pulls on levers or cams at the brake assembly, pushing the shoes or pads against the drum or disc, just like we discussed. And crucially, as you pull that lever up, there's that ratchet mechanism, a little pawl clicking into teeth that locks it firmly in place at whatever tension you've applied. Holds it there until you hit the release button and lower it. The whole system gives you what so many people value: direct control. And that term, direct control, what does it really mean here? It means there's no electronic middleman. Your muscle power goes straight through the cable to the brakes. It's a connection many find really reassuring, intuitive, almost comforting in its simplicity.
Yeah, a direct line to the mechanics. I get that. And when we talk about that lever, it's not always in the same place, is it? Like everyone pictures a handbrake between the seats.
Yeah.
But there are other ways they did it, some you still see occasionally.
You're spot on. The placement isn't totally standard, and how it's changed kind of reflects shifts in car design. The handbrake lever, right there in the center console between the seats, that's definitely the most common, the most iconic, especially in cars with the manual gearbox. But you also have foot-operated parking brakes, usually a smaller pedal way over on the left side of the driver's footwell, sometimes near the main brake pedal, sometimes a bit higher up. These are definitely less common now, and you mostly find them in older automatic transmission cars. And the reason is pretty simple. In a car with a manual transmission, that space in the footwell is obviously taken up by the clutch pedal. So for manuals, the hand lever just became the standard ergonomically. But the key point, whether it's a lever you pull with your hand or a pedal you push with your foot, is that both types maintain that fundamental physical mechanical connection. They rely solely on cables and levers, not electronic signals. It's that direct, almost analog feel. It kind of represents a certain philosophy about driving, emphasizing driver input.
Okay, mechanics covered, different types noted. Now let's really dig into why. Why do so many drivers, especially the enthusiasts, still champion the manual parking brake? What are those core advantages that keep it so relevant even as cars get smarter and smarter?
Well, the first one, and maybe the biggest for a certain type of driver, is exactly what you mentioned earlier, that unmatched tactile feedback and direct control. That physical sensation of the lever, the resistance you feel, that clicking sound, it's not just noise, it's information. It gives you a real immediate sense of connection to the car's mechanics. A lot of drivers, not just hardcore enthusiasts, prefer this because they feel genuinely in control. They have a sense of exactly how much brake they're applying. It's not just about feeling good. It's about understanding the car's state in a very direct way. And beyond just the feel, there's the simplicity and the resulting reliability of the design. People often call manual parking brakes practically bulletproof, and that's mainly because it's just straightforward mechanics. You've got a lever, a cable, the brake parts. That's pretty much it. There aren't complex electronic control units, no software to glitch out, no sensors to fail in the same way. This mechanical purity means fewer complex things can go wrong. Think about older machines or even backup systems and say aircraft simplicity is often valued for robustness, right? A steel cable, yeah, it can stretch or eventually wear out, but it's generally very resilient against the kinds of electronic failures like power issues or software bugs that can sometimes affect more complex systems. And that simplicity leads directly to another major plus: ease of service and repair. This is huge for owners and mechanics. If something does go wrong with a manual parking brake, it's usually way easier to figure out what the problem is and fix it. The parts, like the steel cables, they're relatively simple, generally inexpensive, and you can find them easy to find almost anywhere. The source material points out, and it's largely true, that pretty much anyone can fix a manual brake. Basic tools, a bit of mechanical sense, and you're often good to go. There really are not a lot of parts to break in the first place, and troubleshooting is mostly visual, mechanical. You don't usually need special diagnostic computers. Compare that to the proprietary tools and specialized knowledge often needed for electronic systems. Fixing a manual brake can be way cheaper and more accessible. Sometimes it's just a quick cable tensioning, which is practically free if you do it yourself. Then there's a really critical safety angle, one that maybe doesn't get talked about enough: emergency braking control. Think about a worst-case scenario. Your main hydraulic brakes fail completely. It's rare, but it happens. That big, obvious lever or pedal for the manual parking brake is just inherently easier to reach or grab in a panic compared to fumbling for a small button. But here's where it gets really interesting. A manual parking brake allows for what's called one-to-one actuation. This means you, the driver, have direct analog control over how much force is applied. You can modulate it. So imagine you're going down a hill, brakes fail. Just yanking the handbrake lever hard could lock the rear wheels instantly, sending you into a skid. Very dangerous. But with a manual lever, if you have the presence of mind, you can feel the brakes starting to bite and carefully, progressively increase the pressure. You can sort of feather it, applying just enough force to slow down controllably, hopefully keeping steering ability. That ability to slowly ramp up the braking force to stop safely from speed is something an on-off electronic button just can't replicate in the same way. In that high-stress moment, that physical control, that power to modulate, it could honestly make the difference between a bad situation and a disaster. It gives the driver a direct tool to try and regain control.
Wow, yeah, that point about modulation in an emergency is huge. It adds a whole layer of control you might not even think about normally. But okay, nothing's perfect. The manual brake isn't without its downsides, right? What are the main disadvantages that balance things out? Well, yeah, and maybe the biggest disadvantage, ironically, circles right back to that human control we were just praising. The argument often made is that the main disadvantage is the driver themselves. Because it relies entirely on you for correct operation, there's real potential for misuse, especially under pressure. In a panic, that gut reaction might be to just yank that lever as hard as possible. And doing that can absolutely lock the rear wheels, possibly sending the car out of control, just like you said. So it highlights that need for proper training, or at least understanding, and a calm approach to modulate effectively, which, let's be honest, isn't always easy in a crisis. So while it offers ultimate control if you're skilled and calm, it also carries ultimate risk if you panic or don't know how to use it properly. And then there's the maintenance aspect. You mentioned bulletproof simplicity, but those steel cables aren't totally maintenance-free, are they? They're under tension. They're exposed to weather, road grime.
Exactly. They stretch over